Good afternoon, everyone, and welcome to Commencement 2019. I see we have one last test for our undergraduates, and that says musical chairs. Okay. Okay. So, my name is Nils Halverson. I'm a professor and chair in the Department of Astrophysical and Planetary Sciences. So, new this year, we're having a combined graduate and partial undergraduate ceremony, and thanks to our undergraduates who have agreed to walk today. We were filled to capacity yesterday. We had every seat in the house full, and we still couldn't accommodate all our undergraduates. And that's because our program, our undergraduate majors program, is the largest in the nation. We have over 350 undergraduates. So we proposed a solution to build a new, larger, and better planetarium, and the provost has not agreed to that yet. So I just want to tell you that a reception is going to be following the ceremony out here in the exhibit area, outside the planetarium afterwards. You're all welcome to join that reception. Graduates are going to be called up by name to receive their diplomas, and our undergraduates may say a few words if they wish after receiving their diploma, and then our undergraduate program assistant and in-house professional photographer, Jose Alberto, is going to take pictures as both undergraduates and graduate students receive their diplomas. So I'm going to speak broadly now to both our undergraduates and our graduate students. Oh, thank you. I forgot that yesterday. So you may be seated. Thank you. Thank you, Zach. Okay, so to our undergraduates, you've completed a rigorous course of study. You've grown as scholars and more broadly as human beings. You've completed Starfleet Academy, which is a 2-semester course for our majors in either astrophysics or planetary sciences. Some of you have done both. You've learned about everything from subatomic particles to the cosmic horizon, some 13 billion light years distant. And I always emphasize this in goals in my courses, and it's certainly true for goals for both our undergraduate and our PhD degrees. Knowledge is important, and you've accumulated a great deal of knowledge. But what's more important is the skills that you've gained. You've learned how to think critically. You've learned how to think scientifically. You've learned how to approach difficult problems, how to learn on your own, how to be independent, critical, scientific thinkers. You've also embraced the discomfort of the unknown. That in science we disprove or support a hypothesis, but we are always open to revising our theories based on new evidence. So your skills are going to make you much sought after in a wide variety of professions. Not only in academia, as astrophysicists and planetary scientists, but in education, in research, in innovation, and in developing policy. So, beyond skills, as part of your liberal arts education here in the College of Arts and Sciences, you've gained perspective and insight into humanity's place in the universe. Astronomy is an age-old endeavor and a field that touches us all. And I was reminded of that most recently by this beautiful first ever image of a black hole that was recently published and widely viewed. And that not only was it scientifically unbelievable and amazing verification of our theories of black holes and their accretion disk, but it also really touched us as humans, as evidenced by the broad press coverage that it received. So you all now are experts and ambassadors with a truly cosmic perspective, and it's your responsibility to go out and to share your knowledge, your insights, your wisdom, and most importantly, your scientific, evidence-based way of thinking with your fellow humans. So congratulations and welcome to the community of scholars. Okay, so let's see. So I now want to introduce to you our graduating PhD student, Becky Nevin. She's going to, along with Nick Conant, offer a short planetarium show. And after that, we'll proceed with the rest of the ceremony.
Okay, thank you so much. Before we get started, Nick and I have prepared for you about a 15-minute long show to just really run the planetarium through some of its paces, and also to showcase what the graduating students have accomplished during their time here at CU. But before we get started, logistically, I know this is a graduation ceremony. You're ready to take a lot of pictures of your loved ones. However, this is the dark dome part of the experience. So if you take a flash photo in your neighbor's face, they might not be happy. So please refrain from photography until the end of the show. I think Nick has offered to bring up some beautiful things on the dome afterwards, maybe, if we want to look at some of those later. Okay, but sit back and relax. Okay, so this is an astrophysics and planetary sciences department, and that means that we cover just a variety of scales of things in the universe. And so my goal for today is to really showcase what the graduates have been doing and to hopefully inspire you and excite you simultaneously. So we begin here on CU's campus on Farron Field. I wish that today looked like this, but fortunately it is better than yesterday. And we like to look at the sky. And we specifically as astronomers like to look at the night sky. As you can see the moon traveling across the dome. And now it's approaching nighttime. And we in the planetarium are lucky to have complete control over this. We can shut off all the light pollution in the city of Boulder and show you a view that you might see from the countryside or from the mountains. One of my favorite things about summer is that you can actually look to your left, which is the east of the sky, and see the Milky Way rising. The Milky Way will be highest in the sky around midnight during the summer. And I think the Milky Way is actually one of the best named things in astronomy. It does look like spilled milk. And that's because what you're looking at is actually hundreds of billions of stars in the plane of our own Milky Way galaxy, along with just a variety of gas and dust. I think I said the other day that light is one of the most important tools of astronomers. And here we can look at visible light that's slightly enhanced. You wouldn't see this with your eyeball. In the plane of the galaxy, Nick has made the Milky Way more beautiful for us. We can also look at different types of light to learn about our sky. For example, one type of light is far infrared light. And it really makes the Milky Way stunning in a different way. Infrared is like looking at heat vision goggles at the sky. And what it really highlights for us is the dust in our galaxy. And dust is so, so critical because it is the material that forms planets, for example. Nick Kruchek has been studying this dust in the interstellar medium between stars in our galaxy. And this dust is actually very, very faint, the dust that he's studying. So he uses ultraviolet sounding rockets to do this. And he shared with us a clip of one of the recent launches. Stunning, but we're an entire planetarium full of people and we'd like to lift ourselves into space. So no offense, but to do that, we're gonna have to use a slightly larger rocket. We'll use the Delta IV heavy rocket to do this. Let's go ahead.
Rotate ignition. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay, now let's pretend we're in space. And we can do that because this planetarium doesn't just look up from the ground. We actually have the unique capacity to look down on our stunning home planet from above. And I think this just really throws things into perspective. We are a tiny planet in a vast universe. We can also look at the atmosphere of the Earth and see just how thin it is. The atmosphere is one of the things that's protecting us from the harmful radiation of space, specifically mainly from the sun. But the atmosphere cannot do this alone. We need more protection because the harmful particles that are streaming from the sun can do things like wreak havoc on our DNA or just really mess with our power grid. Take your choice. And to protect against them, we need things like the Earth's magnetic field, which is a complicated but very important structure that surrounds and protects Earth from particles from space. Andrew Sterner has been studying the boundaries of this magnetic field, learning about what happens with turbulence on these boundaries. This is really critical science. But of course, these harmful particles are coming from the sun. So if we want to understand more about them, we can actually head to the center of our solar system and look closely at our star, the sun. And actually, the National Solar Observatory is in Boulder, so we tend to care a lot about our sun. And people can learn about it in different ways. For example, Gabo Ortiz-Pena has been looking at simulations of convection within the sun itself, and this is so critical because the sun makes its energy at its core, and this energy has to rise to the surface somehow. He studies these circular motions called convection, and he put it really nicely the other day. He said, it's basically water boiling in a pot. We all know that. But this is happening within the sun, and he would like to understand, using simulations such as this one, how exactly this works. Here you see the red fluid is rising, and the blue fluid, it's cooler, it's sinking. I think we'd be selfish to think that the sun only affects us in our solar system. It's also important for the other planets. We can talk about the connection between the stars and the planets of a solar system. And a great way to look at this is the red planet, Mars. We also love Mars here at CU Boulder because of the MAVEN mission, which is a great acronym, the Mars Atmospheric Volatile Evolution Probe, love that one, which is studying the atmosphere of Mars and how it was lost over time. Hillary Egan, who defended her thesis this morning, is studying how the atmosphere has changed over time using these simulations and asking really critical questions, such as how is air in the atmosphere lost over time? How does this apply to other planets in our solar system? And how does this apply to exoplanets, which are planets outside of our own solar system around other stars? In the last couple of decades, you'll start to see some colored dots showing up on the dome. These are the thousands of discovered exoplanets in our solar system. We now think that there's on average 1 or 2 exoplanets per star in the Milky Way galaxy. And I told you earlier there are hundreds of billions of stars. So you can do that math. That's an incredible number of other worlds out there. What you're seeing are previously discovered exoplanets, and some of them are in clumps because they have been found by the same space telescopes. Here is the Kepler Space Telescope rising over the stage. It has uncovered thousands of exoplanets around other stars. So we can begin to ask questions with these other worlds. Like, how did we become a solar system? Is our solar system really that unique? Are we different from all of these other planetary systems? And one great way to think about this question is to travel to a region of intense star formation that I think is really visibly stunning too. This is 30 Doradus. This is a region where a lot is going on. You might notice some very, very bright stars. Some of these stars are much, much brighter than our own sun. They are called O-type stars, which is just a naming scheme astronomers have come up with that is not in alphabetical order for stars for historical reasons. But these O-type stars are so critical because they're just vastly different in their short, violent, and very bright lives than our own sun, which is a G-type star. Ryan Diaz-Perez has been studying convection within these O-type stars, and he thinks that convection actually happens in multiple layers in this very exotic type of star, and that's very exciting. Also, in 30 Doradus, there's multiple sites of new formation. This is like a nursery for young systems. Protoplanetary disks can form here. These are the beginning of planetary systems. These are some actual images of disks. Dan Gohl is using simulations to learn about the initial conditions of these disks. He's asking important questions like, how do turbulence and magnetic fields in these disks actually affect the formation of planets? And of course we care about that because of our own solar system. So now we've looked at dust, gas, planets, stars within our own Milky Way galaxy. But our own galaxy is not the only galaxy out there. We're not alone in this universe. And so we can actually leave our own galaxy at speeds greater than the speed of light. And now we're traveling out of the plane of the Milky Way galaxy. And keep in mind that we've never taken a picture of the Milky Way galaxy from outside of it. This is a scientist's and artist's impression of what it looks like from the outside based upon all of our research. But again, it may be beautiful, but we are not unique. There are more galaxies out there. In fact, we're able to map the sky with these galaxies in it and learn about where they live. We have a lot of nearby galaxies that you're seeing now labeled. These are our local group of galaxies, our neighborhood. And we've learned that within every one of these galaxies, there's a supermassive black hole near its center. And this is what I research. And now we're beginning to see the clusters of galaxies in the universe. And there are some very, very large clusters of galaxies. I always have trouble locating it, but the Virgo cluster is in here somewhere. I think it's on the right, towards the bottom. And this cluster has a very famous galaxy that was mentioned earlier, the galaxy M87. It's been in the news. And it's been in the news because astronomers have managed to image, for the first time ever, the event horizon of a supermassive black hole. This is this sort of fuzzy, I've heard it said this is a fuzzy image. I think it's a beautiful image of this supermassive black hole. And this really makes me think that black holes are the biggest paradox in the universe because they're simultaneously so dark, they don't let light escape, yet they can also be one of the most energetic and brightest objects. For example, this is M87 from a little bit farther away. you can see a jet that's driven by the central supermassive black hole. I like to study winds that are driven by supermassive black holes that might affect their galaxy around them. And so all of these galaxies that we're seeing in the background, they have all evolved. And we can study them using galaxy surveys, which map all these little pinpricks you're seeing are actual data sets of where these galaxies are located in the universe. And as we move farther and farther back, away from our home, we're actually moving back in time through the 13 billion year old history of our universe to the beginning of it. And at the very, very beginning of the universe, we can see this surface begin to appear around us. This is the cosmic microwave background radiation. This is some of the earliest light from the history of the universe. And what you're seeing between the red and the blue are tiny, tiny variations in the early universe on the order of 1 in 100,000th of a degree Celsius. Sam Walker is using development of very, very sensitive instruments just down the street at NIST to learn about even smaller variations in this cosmic microwave background using polarization. Wendy Everett is using a telescope at the South Pole to also learn about this cosmic microwave background. So these tiny, tiny variations in the cosmic microwave background will evolve throughout time to become the structure that we see in the universe today. Things like galaxy clusters, galaxies, supermassive black holes, stars, planets, gas and dust. You, basically. And so as we begin to return to our home, I want you to think about the fact that even though we all at the University of Colorado have studied just a vast array of things on different size scales and time scales, we're all really united by the same basic questions, which are, how did we get here and where are we going from here? And I think, cheesily enough, these are also excellent questions to think about as you are no longer a student, but looking towards your future. And so, for my last planetarium show here, I would like to end with a quote from Carl Sagan. The size and age of the cosmos are beyond ordinary human understanding. Lost somewhere between immensity and eternity is our tiny planetary home. In a cosmic perspective, most human concerns seem insignificant, even petty. In the last few millennia, we have made the most astonishing and unexpected discoveries about the cosmos and our place within it. Explorations that are exhilarating to consider. They remind us that humans have evolved to wonder, that understanding is a joy, that knowledge is prerequisite to survival. I believe our future depends powerfully on how well we understand this cosmos, in which we float like a mote of dust in the morning sky. Thank you so much.
Thank you, Becky. Fantastic, Becky. Thank you. I think that Carl Sagan quote was a great transition, a great way to end and talk about why we do what we do, why we have astronomy majors. And I think that was a great description of why lots of us went into studying astronomy. So my name is Seth Hornstein, one of the faculty members in the department, and it's my pleasure to announce the graduating undergraduate class of 2019. Undergraduates, you have one last challenge, and that is, now that we've done all this seat shuffling, I'd like you to line up on the back of the wall in reverse alphabetical order. You may begin. And while they're doing that, I'll explain why. In 2018, there was a nationally recognized study from the Department of CU Economics that found that students whose names are at the front of the alphabet are recognized more and even go on to have more success because of our tendency to alphabetize virtually everything. So today, to even the playing field just one little bit for those folks that they described as alphabetic injustice, we're going to go in reverse alphabetical order. Students, when your name is called, please come up. Dr. Halverson will present you with a diploma. Pause for a moment so our photographer, Jose, can get a picture of you and document the occasion. And then you have the invitation to say a few words at the mic, and then head down the opposite side of the stairs. So without further ado, let's begin. Cooper Wooten.
I want to thank my very supportive family, as well as Brain and Baganol, who have helped me a great deal as well.
Sabrina Troncoso.
Thank you to my family and all my professors. I couldn't have done it without you. Dr. Brain and Dr. Snyder, thank you.
Tyler Shelley.
Thanks to the amazing faculty here at CU. I think the APS department is really a special place. Thanks to my friends and family as well, everyone that supported me. I don't know if there's anyone that didn't support me, but I want to thank them too for their criticism. That helped me too.
Sham Putnam.
I just want to thank my wonderfully supportive family for helping me through this journey. Of course, the wonderful professors, and especially my long-term mentor and friend, Mark Johnson. Couldn't have done it without you. Thanks.
Grace Marshall.
I'd like to thank my whole family for coming out, and thank you all APS. I had a great time.
Jonathan Lutz.
I'd just like to thank Wikipedia, Stack Overflow, and free online textbooks.
Dylan Gatlin.
To many here, I'm a student. To many here, I'm a peer. And to many here, I'm also a teacher. And I look forward to, some of them are already here walking with me today. They managed to catch up. And I look forward to watching all the others who I taught over my time here walk as well.
Jeffrey Daniel.
Just want to thank my mom, dad, my brother Tom, and Donna Norton for all the support you've given me over the years. Thank you.
Luke Charbonneau.
smile, my nanny, and my sister, who's my best friend. So.
Quinton Center.
I want to thank my family for coming out today, and always keep looking up to the stars.
Christopher Benben.
I just want to thank my family, my dad, mom, and grandparents, and the whole department here, particularly Dr. Schneider. Thank you all.
Ladies and gentlemen, the graduating class of 2019. Now, before we get to our graduate students, bridging the gap between our graduate students and our undergraduate are our TAs. In a department that prides itself on fantastic teaching, having fantastic TAs help us get there. Today, I'd like to recognize 4 of our graduate students who've been awarded with outstanding APS graduate TAs for the year. So, graduates, if you would come up when your name is called. Let's see. Abhishek Kumar. There you go.
I'd like to thank Fisk and Dr. Jason Glenn, who were pivotal in helping me get a secure job here at the APS department. And I would also like to thank Dr. Seth Thornstein for scheduling me for all these wonderful classes that I've taught, and my peers and fellow TAs for helping me throughout the process. Yeah, thank you so much.
Angie Harkey-Hoseman.
I'd like to thank the undergraduates who have actually taught me quite a bit in my time as a TA.
Unable to attend today, but worthy of recognition as well, Daniel Everding. Girish Devuri.
Thank you to the department, and hopefully the students agree that I deserve this thing.
Sorry, Girish. Our turn to Dr. Nils Halverson.
Okay, thanks, Professor Hornstein. So I now want to recognize our Masters of Science degree awardees. So each recipient will come up and receive their hood from their advisor and then make a few remarks. So the first is Ryan Diaz-Perez and his advisor, Professor Ben Brett.
Hood first, then tie. All right. This is a test of me.
Ben, would you like to say a few words?
Sure.
about
I'll say a
Ryan
couple
first?
things. I'll say a couple quick things about Ryan. About 2.5 years ago, bright, happy Ryan shows up into my office. He's like, I'd really like to do research with you on neutron stars. They seem really neat. I'm like, neutron stars? Those are hard. I don't know how to do anything about this. Oh, but they're really, really neat. Maybe we could do something else. It's a little easier. Well, 2.5 years later, we are still trying to figure out the easier problem that Ryan started on. But Ryan has brought joy and perseverance every day to tackling hard problems in astrophysics. I've enjoyed every day I have gotten to work with Ryan. I look forward to all of his adventures going forward. Doesn't have to involve me.
Le quiero dar muchas gracias a mi familia y a todas las personas que me ayudaron y que los sueños sí se pueden.
All right. Next, oh, I'm sorry, Ben, you're up again, right?
That's right.
Okay, sorry. Sorry, I was confused. Okay, so next I'd like to invite up master's degree recipient Gabriela Ortiz Pena, and again, Benjamin Brown, his advisor.
See if I can figure it out.
Maybe take off your monitor for.
That'll reduce the two.
Yeah.
I copied Dave.
Ben, you want to say a few words first?
Well, not to be outdone by Ryan, Gabo shows up in my office and he's like, turbulence. That's interesting. I'm like, Gabo, you know we've been thinking about that since, Leonardo da Vinci, like more than 400 years, and no one has any answers to it. That is the problem I would like to work on, nonetheless. Gabo's done a brilliant job of that. I have, in addition to our scientific discussions, deeply enjoyed my discussions with Gabo about how we can all make a larger impact on the world around us and contribute to our societies. I look forward to seeing all the ways that Gabo does that going forward, and I've enjoyed my time with Gabo over dinners and work and conversation intensely.
I'd like to thank my family, my brother Isaac, my mom Sandra, my lovely partner Lorena, for coming here and supporting me and for being there for me the whole time. I'd like to thank Ben for his lovely words and for having those discussions with me. It's been a great time. Thanks to all of you.
Okay, and last of our master's degree recipients, I'd like to invite up to the stage Samantha Walker. And I'm Samantha's co-advisor, so now I'm switching hats to co-advisor. So, now I'm going to do this right up to make it fun. Okay, can you take off your hat? Congratulations. All right, so let me say a few words about Sam. So Sam got her undergraduate degree at Fordham University, and I still remember when she was still a prospective graduate student, we Skyped. And I think you were sitting on your bed at home, and I was like, wow, she looks really young, you know? But she has come a great distance in the last few years. She's tenacious, smart, and she really ventures out to tackle new problems. She is the recipient of both an NSF Astrophysics Graduate Student Fellowship and a NASA NESSF Fellowship, which she had to decline so she could take the NSF one. And then most recently, she's the alternate and honorable mention for a Ford Foundation Fellowship, so she's doing awesome. So,
I would love to thank my family for all their support. I would also like to give a shout out to the grad students in this department. They've been a really supportive community. And I'd also like to give a shout out to Niels, who I'm getting to know better through his co-advising. And I look forward to working with you on my PhD.
yeah, you do. Okay, now I would like to introduce our PhD recipients. The first one is Dr. Hillary Egan and her advisor, Professor David Brain. The little curly thing goes down. That's right. Dave, why don't you give me? Okay, one more, two more. Yes, okay, now invite Professor Brain to give a few remarks about Dr. Egan.
Hillary's having a big day today. It turns out her thesis defense was at 9:30 this morning. And so you'll have to forgive her if she's glassy-eyed and not really listening to any of this right now. I'd like to tell you first a little bit about her thesis research and a little bit about her, but I'll try to be very brief. Hillary studied planets around our star and around other stars, and she studied how their atmospheres escape away to space. This is important because it turns out you need an atmosphere in order for water to be liquid on the surface of a planet, and all life needs liquid water. So she's motivated by habitability of planets, but she studied charged particles and magnetic fields and how planets interact with charged particles and magnetic fields coming from the sun. And I'm really proud of the way that she did this as a true scientist, which is not about the answer, but instead about the journey and understanding why that answer resulted. And all three of the chapters of her thesis showed this. In the first chapter, she studied Mars in our own solar system and compared 5 different models from around the world to see which ones did best and under what conditions and why. In the second chapter, she studied Mars if it was orbiting an M-dwarf star that Becky talked about earlier in the planetarium presentation. And instead of just giving the answer, she used her model to turn each knob one at a time to understand which knobs were the most important when we move Mars from our solar system to another solar system and think about that situation. In the third chapter, she went big and she gave Mars a magnetic field, which it doesn't have. And she challenged the idea that's been around for more than 30 years that you need a magnetic field to protect your atmosphere from being stripped away to space. Hillary showed that it's much more complicated than that. And actually, sometimes having a magnetic field hastens the escape of an atmosphere from a planet. That's her research. Let me tell you a bit about her. She did all of this in 3 years, almost to the day, since joining my group. Graduate school is typically a 5 or 6 year process, but Hillary made a change partway, and she had to come up to speed on the literature, the techniques, what a planet was, because she was studying galaxies before this. I'm just so proud of how quickly she did all this. She did all this while supervising 2 undergraduate students in my department in my research group, playing Frisbee in the national championship on ESPN, coaching multiple Frisbee teams, playing on 470 other Frisbee teams, and that's my estimate, and being an overall asset to our group that really made all of us better as she was doing it. She's an outstanding computationalist. She's outstanding with theory. She gives great talks and has won a Science Communication Award as she's done it. And I'm really proud to be able to call her my first PhD student. And I'm excited to see where her career goes, and particularly excited that we get to hold on to her for at least a little bit and continue to benefit from what she's done.
I think all of today for me is just thanking everyone who's helped me out with this amazing process. But again, I want to thank my family, my friends, everyone for their amazing support through this really challenging process. And then beyond all that, Dave has been a fantastic advisor, and I wouldn't have been able to do the research that I have been able to without his constant support, supervision, and general encouragement and positive demeanor. So I'm infinitely grateful to him as well.
Our next PhD recipient is Dr. Wendy Everett. And I'm Wendy's PhD advisor, so I'm going to hit her. If I can figure it out. Very complicated. Wendy's been a wonderful PhD student. Her title of her PhD thesis is Point Source Analysis, Hardware Development, and Focal Plane Characterization for the South Pole Telescope. And that was shortened by about a factor of 3 from her original working title, which still appears on the signature page of her thesis. So for Wendy's PhD thesis, she sort of did things in reverse. Usually students in my group, they develop an instrument, they field it, and then they analyze the data from that fielded instrument. Wendy analyzed the data, then developed the hardware, and then fielded the instrument. And she was able to do this because we are members of a collaboration called the South Pole Telescope, which has had multiple generations of cameras on it. And Wendy, for her first project, analyzed point source populations in the original cameras called SPTSC, 2500 degree field of view. And in so doing, has given us more details about the different radio frequency emitting point sources, including lensed, distant, very distant galaxies that are bright but rare in the radio. She then went on to develop hardware, including the detectors, the very exquisitely sensitive bolometric detectors using superconductor technology that go into the South Pole Telescope in its latest camera called SPT-3G. She's been to the South Pole twice, 3 times in her tenure here, and following the latest deployment, she has been busy characterizing our on-sky performance of our camera. The scientific goal of this current generation of instrument, which Wendy has helped develop, is to uncover the tiny signature in the cosmic microwave background from gravitational waves due to inflation, which was thought to be a period of rapid exponential growth when the universe was less than a second old. So let me say a little bit about not Wendy the scientist and Wendy the scholar, but Wendy the person. So Wendy obtained her undergraduate degree from Oberlin Conservatory and Oberlin College. So in the conservatory, she received a bachelor's in music performance in bassoon, and from Oberlin College in physics. And like all great, depthful, indecisive minds, yourself included, and I relate, she traveled after college, spending a lot of time in India, and also working at the University of Chicago on the South Pole Telescope before we successfully recruited her to come here for graduate school. She's an avid rock climber, and she is, I think, embraced Boulder and all its outdoor spirit. And so Wendy is not only a wonderful scientist and scholar, she's a multidimensional, wonderful human being, and I look forward to seeing what you'll do next. Congratulations, Wendy.
I'd just like to thank my family. My parents were here, and huge thanks to Nils for many, many years of awesome support. And big thanks to everyone in the South Pole Telescope Collaboration who I have learned an immense amount from, and I feel really honored to have been able to call them collaborators and friends for so long. So, thanks.
Next, I'd like to invite PhD recipient Dr. Daniel Gohl. And his advisor is Professor Phil Armitage. Phil.
Thank you. So it's a pleasure to be the first to congratulate Dan. It's been a real pleasure and a privilege to be working with you these last few years. Dan's also worked very closely with Jake Simon here, so I'm delighted that Jake was able to be here also to also congratulate Dan on this achievement. So together we've been working on problems in studying protoplanetary disks, and I would say Dan's really embraced my spirit of research, and I think many of our spirit of research in just trying to see where things go and have a very exploratory and sort of fun approach to looking at new problems. And maybe I'd particularly thank Jake. Perhaps sometimes I take that a little bit too far and encourage Dan to just try random things because maybe they'd be fun. But it's good to have someone younger with more experience, perhaps, to say, well, actually, we do need to publish something and actually get somewhere. But it's been really tremendous fun, both scientifically, and then we've been presenting this work at various places. We spent some time in Santa Barbara, which is always fun, and in Arizona, and telling our colleagues about it. So a few words about what Dan's done. He's been studying protoplanetary disks. So these are disks of gas and dust around young stars. You saw some beautiful images of protoplanetary disks on the dome during the presentation earlier. We've been doing purely theory, computer simulations, so they're beautiful in their own way, but they're a little bit different. And specifically, Dan's been looking at what the role of magnetic fields in these disks are and how small solid particles start growing together in really the very first steps of planet formation. So he's found some important things in the course of that work. Of course, as is also the case, he's also found a lot of puzzles and surprises and things that will maybe motivate future work. So there'll be a lot to be done moving forward. So thank you, Dan, and be the first to wish you every success in your future endeavors.
I just wanted to briefly add that I thought I was a very organized person until I met Dan. So I commend you on that and his amazing Python abilities to make plots all flow into one nicely organized movie type format. I'm going to have to get that script from you.
Thank you. I'd just like to briefly thank my family who's always supported me, and my parents, Tom and Lisa, who made the trip here. And also, of course, everyone in the department, all the Phil and Jake back here, who have been great advisors for 5 years now, and have led me to good things, I think, in the right directions usually. And of course, also just all my grad student cohort here, and people and friends not here, and bandmates and Frisbee mates, and everyone who's made this just a really great 6 years to spend in Boulder. It's been a great time. Thank you.
Next, I'd like to welcome Dr. Nick Khrushchev and his advisor, Professor Kevin France.
Hi, I'm Kevin France. I'm Nick's PhD thesis advisor. So let me tell you just briefly about what Nick's done. Nick led off the nice presentation that Becky made. We saw one of Nick's rocket launch videos. That was from the Marshall Islands about a little more than a year ago now. Nick launched 2 sounding rocket experiments through a program that we do with NASA. He took an experiment that we had put together but not optimized, and actually brought the instrument to its full scientific performance in those 2 flights. It was a very exciting opportunity to work with Nick. This instrument that he was building is a prototype for one of the modes of an instrument that we're imagining as a successor to the Hubble Space Telescope. So the work that Nick has done in terms of developing the technology is something that we hope to take advantage of for the next at least 2 decades. Scientifically, Nick's work was studying the gas and dust that's in the interstellar medium. This is the space between stars. This material will eventually coalesce under the force of gravity to become the next generation of stars and planets. And so Nick was basically making this first characterization of these raw materials for future stars and planets. So very exciting. One other, I guess, little things about Nick. So Nick and I have been working together for about 4.5 years now. Nick was working with Nils and on these precision cosmology experiments, and where they're worried about things, at like 0.01% precision, which is very hard, and to most astronomers that just seems way more than the necessary factor of 2 that we think that it's about right. Nick heard that I was more of the factor of 2 kind of person, and that we had the opportunity to shoot things into outer space, and so we started working together, and then over the course of that, like I mentioned, we launched 2 sounding rockets, one from White Sands and then that one from the Marshall Islands. As Nick became more comfortable, he began to feel more secure in joking about the fact that I'd turned 40, which he seemed to continually get wrong as 50, but he didn't have his PhD at the time. So we were in the Marshall Islands for about a month last year, and we had 5 nights to launch this experiment and 5 hours per night to launch it. And the winds weren't right. We couldn't get this thing off. And we stayed up every night for these 5 nights, and we were really worried that we weren't going to get it off, and we were going to have to leave somebody with the experiment on the Marshall Islands. Now, Nick had this little problem, is that he was getting married a little bit afterwards. And so, but it was Nick's experiment, so he was the natural person to stay behind in the Marshall Islands for the 3 or 4 months that was required. But to the benefit of Nick's future happiness, 13 minutes left on the last night of our 5-night launch window. We got a 30-second break in the weather. They hit the button, and Nick's thesis work was completed. Well, I guess the hard work started at that point, and he was able to wrap everything up. So I have to say that Nick's one of the hardest working students that I've ever worked with. It's been a real pleasure. He's been a great advisor to younger students, not just our undergraduates, but also the junior graduate students that he's taught a lot to. And the last thing that I'll say is that I had a job ad out last year looking for a new postdoc, and I got all the applicants, and I realized about halfway through that none of them were what I really wanted to hire, which was somebody like Nick. And so, so after reading all of my applicants, I just look forward to Nick continuing to work with our group over the next several years. Thank you.
Wanted to thank Kevin for never asking how many things I broke in the lab along the way. It might be the old Colorado Fifi mindset, but the ability to just kind of dive in and define your own path to assembling a rocket is an incredibly rewarding experience. My family's grown too large to thank them all personally, but they were incredibly supportive, in particular my dad for teaching me the importance of hard work, my mother for her boundless compassion, my wife Bethany for reminding me to breathe along the way, and my mom for leaving with me the importance of education. Thanks.
I'd now like to invite to the stage Dr. Becky Nevin and her advisor, Professor Jeremy Darling. Not my fault. And her advisor, did I say Professor Julie Comerford?
Despite not being Jeremy. I do have a few things to say. I've really been looking forward to this. 6 years ago, my first semester as a professor at CU, I was giving a talk about my research to the new cohort of first-year graduate students. And at the end of my talk, I asked if there were any questions, and one eager hand shot into the air and asked, "Are you taking on students?" And that's how Becky became my first graduate student. And after that, we had our first meeting together where we looked up a graduate fellowship that Becky was eligible to apply for, but the deadline was in 4 days, which is clearly not enough time, but Becky's exact words were that it didn't seem too ridiculous to write an entire research proposal from scratch in 4 days as a first-year graduate student. And so she went ahead and did it and ended up winning the fellowship. And that was my preview to what the rest of Becky's graduate career would look like. So Becky's research has been ranging from how supermassive black holes affect their host galaxies to developing creative new ways to identify merging galaxies. And most PhD theses focus either on observations or theory, but Becky chose to do both. And she's led her own observing programs at Apache Point Observatory, running the telescope there. And she's also worked with theoretical simulations of galaxy mergers, where her analyses are so big and complex that she has to run them on the campus-wide supercomputer. And she's gotten so adept at using this supercomputer that a couple weeks ago she got in trouble for running too big of an analysis on the supercomputer, which I think just means it's time to move on to bigger and better supercomputers. So when I think back on Becky's time at CU, there are a couple of things that stick out. There was the time that we were going to discuss a research paper in group meeting. Becky showed up to group meeting having already downloaded the data from the paper, analyzed it herself, and come to a different conclusion than the authors, and explained why they were wrong. So luckily for them, she was not the referee of that paper. There's also the time we watched her compete in the national championship for Ultimate Frisbee on ESPN live stream. I think they came in as the number 12 seed and got second in the nation. And then they're going back in a couple weeks to win it this year too. So go Team Cali. And then there's just Becky's general ruthlessness when it comes to statistical analyses. She's raised the statistics bar for our entire group, and she's been a role model for the students in our group. And each of us has a paper or project that simply could not have progressed without Becky's contributions. So in short, Becky is the kind of student that every advisor hopes for, the kind who takes off and does brilliant things and makes you look good, even though you can't take any of the credit. So Becky, I'm proud of what you've accomplished in grad school, and I'll be leading the cheer section as you go on and take on the world as a postdoc. So congratulations.
I think we all know that this is not an easy thing to do, and I'm really, really happy to be standing up here today. And I think I would just love to acknowledge my entire support network here in Colorado, as well as all around the world. Specifically, my friends and my cohort, the other grad students here, have been amazing. I think it's so nice that we came here with an amazing year, and that many of us are here in the planetarium together today. Also, friends and my boyfriend Killian, thank you for putting up with me. I'm not a doctor yet, but I swear I'll be more fun in about a month when I hopefully am. Thank you for my mom and dad who are here. I think you guys have really inspired me to just like try hard at everything I do. My dad reads all of my scientific papers, which I think is actually insane. My mom is a lot smarter, so she reads the abstract, which is what you really should do. And also my grandparents are hopefully watching on the live stream right now. They love science, and I think they really encouraged me to continue onward in astronomy, and I would definitely encourage them to continue asking me just like these amazingly difficult questions about particle physics that I have no idea what the answer is. And then to everyone at Fisk Planetarium, I've had such a fun time playing around here in the dome with you guys on my days off or on my days on or just all the time. And then lastly, for Julie, I am Julie's first grad student ever, and I think this has been a long 6 years, and I think that I've changed a lot. I think that I've really grown as a person and as a scientist. And somebody told me, my friend Alex Trumanbach told me the other day that she saw a lot of Julie and how I do science, and I was really, really proud of that. So I'm so lucky to be here with you. And I'm really excited to work with her in the future, too. Thank you.
And our last PhD graduate, I'd like to invite up to the stage Dr. Andrew Sterner and his advisor, Professor Bob Ergen.
Well, as you know, it's, and you may have heard this many times, it's always bittersweet when for a faculty member to see a student who comes, well, a person who comes in as a student leave as a colleague. We're very, very happy to see them graduate, but we're also sad to see them leave because we get to know them and we work for them for a long period of time. So around 6 or 7 years ago, our space plasma group had the fortune, a great fortune, to have 3 launches almost all at once. One was the MAVEN mission, which went to Mars. Another was the now called the Van Allen probes, which had 2 satellites going to the radiation belts. And the third was the magnetospheric multiscale NASA mission, which had 4 satellites that went to the far reaches of the Earth's magnetosphere to study turbulence, reconnection, magnetic reconnection, and particle acceleration. Andrew was on the last of these, the latter of these missions. During that time, our group expanded from, very small, like 6 or 7 scientists and grad students to almost 20 or 25 because of all this great opportunity. And I must say it was one of the most exciting and dynamic times I've had in my career to have all these students and 8 graduate students at one time. And Andrew joined was one of the latter students to join and is one of the last to leave. And so it's with some sadness I see this great era, the era of the launches, we'll call it come to an end. We're going to, of course, we have a new set of grad students and postdocs coming in. And time moves on, but it was a wonderful time with Andrew. So I have to say a few things about Andrew. Andrew is a person of, I think, several passions and deep passions. I know that, for example, he has deep passion for social issues that we've had a lot of discussions on, and I've had a lot of fun on those. He is also a great runner, I understand. I can only plod, so I mean, I can't run that fast. But I understand he's done like one of the top finishers, not the top because it's a hard rate, but one of the top finishers in the Boulder regularly. Our joke was we wish he could write as fast as he could run. Sorry, Andrew. But his writing has gotten faster. And I also understand he loves teaching. And we've talked about that quite a bit too. And he is going on to a teaching career, and I think this is a great thing for the world because he's a very passionate teacher, and I think he'll do very, very well in the future. So thank you for being part of our group, and thank you for all the wonderful times.
I'd like to thank Bob for being there for me and funding for the last 7 years, I guess it's been. And to my other advisors, Stephen Erickson, and my life advisor and first research advisor, Fran Bagenal. Without them, I certainly wouldn't be here today and able to get through to grad school without their support. I'd also like to thank the other graduate students in the program and the faculty as well, particularly the times we've spent working on making the astronomy community a much more equal and equitable place. This has been a really strong passion in our department, and we've made a lot of progress, I think, in the last couple of years locally, and I think it's expanding outwards as well as in different departments as well. So we've made a lot of progress on that. And I'd also like to thank my family who have come out here to support me in this celebratory event. And specifically my uncle, Bill Phillips, who's here today, who from a very early, as a physicist, he has shown me that science is not just a thing that lives in a textbook. Science is a community. Science is something that people do and debate about and learn. And so I thank him for always showing that for me in my life. And I'd also like to thank my partner, Phil. We've been in a long-distance relationship for the last 5 years or so. And so looking forward to ending that and moving on. Thank you.
That concludes our ceremony, and I want to once again remind you that we'll be having a reception out in the lobby afterwards. All of our graduates are invited to first go outside of the planetarium on this sunny day to take a group photo. As the procession, or whatever it's called, leaves the same way, we're going to allow the faculty and the graduates to leave the auditorium before our guests, and I hope that you enjoy the reception. Thank you once again, and congratulations to the class of 2019.